So they have some properties which cancel out with exponents. For example, if the bases are the same, and I say what is 5 raised to the exponent of the log base 5 of 2. So I'm putting the logarithm in the exponent, and the bases match.
So there's no way of doing that on the calculator because it's the base 5, right?
If you were going to do this on the calculator, you could do this. I'll go ahead and show you this.
It's 2, right?
Yeah, these actually cancel out.
Don't you just divide it?
So it's 2. You can't divide.
No, I mean to get log 5 on my calculator.
Oh, yeah, hold on a second. I'll get that in a second.
You did it yesterday.
If you put the logarithm in the exponent spot, since the logarithm is the inverse of an exponent, is the inverse operation, they will essentially cancel each other out.
Always?
As long as the bases are the same.
Oh, cool.
That's the tricky part. So if I say what's...
2.
Pardon?
No, the only thing left in all of that is 2.
Yes, the only thing left in all that is 2. You can do this on the calculator, though. What you have to do is you have to go 5, hatch mark, parentheses. What does the change of base rule say? Who remembers from yesterday? Well, how would you write log base 5 of 2 using the change of base rule?
Log base 10 divided by 5.
What'd you do? What did I change them to? Which base?
10.
10. You got 2 choices on your calculator, base 10 and base E. So I would say log base 10 of 5 divided by
5.
Whoops. It's up to 2. Nope. I would say log base 10 of 2 divided by log of 5. It's got to be the logarithm of both. You'd have to write it like this on the calculator. And if you do this on the calculator, you should get 2. Somebody double check me on that. Make sure I'm getting all the parentheses in the right place. Sometimes this isn't necessarily obvious. Anybody want to tell me if this is right yet? How you doing, Amy? Do you want to touch your text a lot? How fast are your thumbs?
It's 2.085. Is that close enough?
Not really. What'd you do? Should be
I got
exact.
2.
You got 2 exactly?
Yeah.
I didn't put the log in.
Ah, yes. Okay. Yeah. Put the other log in. Be careful of that. Make sure you put the log in. Oh, and when it does the log, if it does the parentheses, make sure you close the parentheses around it when you're on the calculator. But yeah, this will cancel out. Now, sometimes it's not, this property is true, but it's not obvious. For example, I'm going to erase this one. You think of one that's like this, but slightly different, yes. Maybe I'll steal an example from the book to make sure it works. Not that one yet. No, that one's too obvious.
Do that one.
That one is too obvious. That one's too big. Hang on a sec. You're afraid of where it'll go?
I like Goldilocks.
I know, and the 3, it's right. Goldilocks and the 3 logarithms. Let's see.
No, that one's too complicated. No, that one's too obvious. No, that one's just right.
Right. Well, let's, here, actually, let's do this one.
Oh, that's too complicated.
2 raised to the log base.
I'll go 10.
I know, hang on a second. Look at the one that's the same. It's going to be log base 4 of, if we do, I'm not sure I like this one as much. Is there anything we can do with that one?
Can you simplify the 2 and 4? Or
No, you can't directly simplify it.
You raise the log base by 4.
Well, what is log base 4 of 16? What does that equal? 4. Well, that one you can do because you can solve it. What does that equal? 4 raised to the what power is 16? 2. So this is one you should know. So you can just solve it in this case.
And then it counts that as log.
Yeah, well then it's, so this is actually just 2 squared equals 4. That's one that's fair. Okay, that would be one I'd expect you to be able to figure out without a calculator, even though it doesn't directly represent the crossing out property.
So when you square the 4 and it becomes 2, does the log go away?
Yes, you perform the operation.
Okay.
So this is a question. 4 to the what power equals 16? And when you answer the question, all you do is write the answer, which is 2.
Never really gonna have like 5 log as the answer or anything like that, right?
Then why did you square the 2?
Maybe, probably not.
Why did you square the 2?
Oh, because this was 2 raised to the log base 4 of 16 power. The log base 4 of 16
2
is 2. So what I'm being told is to raise 2 to the second power, which is 4. Give an example of a fair change of base question without a calculator.
What is the change of base again?
Change of base is where, for example, if I ask you to find something like, what's the log base 5 of, not something obvious, like 30. Okay, 5 to the what power equals 30. Well, you know it's a number somewhere near 2 because 5 squared would get me 25. 5 cubed would get me 125. So 30 is between 25 and 125. So my answer will be between 2 and 3. Pardon?
How do you write that?
Well, the thing is, what you do is you pull out your calculator, and the change of base rule is the one that says the log base 5 of 30 can be rewritten as the log base 10 of 30 divided by the log base 10 of 5. It can also be written as the natural log. What's the base of the natural log? What's the base of the natural log? 2.71828. What's the letter we use to represent that number? E. The base of the natural log is E. That's important. A very fair question without a calculator.
2.1.
So this is about what?
2.113.
2.113. That makes sense. Since 5 squared would be 25 if 5 raised to a slightly higher exponent. What's a fair non-calculator question where you'd have to know that the natural log has a base of E? What is the natural log of E?
Wait, could you make the E a little bit smaller? Because it doesn't look like... Or wait, never mind. Sorry.
Let's see. Well, this is the same thing as... I see what you're saying. This is the same thing as log base E of E. So this is the question, E to the what power equals E? 1. It's a simpler question than you're thinking. If you have the same base and the same answer here, the exponent has to be 1 because anything to the first power is itself. The thing is, I won't give it to you this way. I'll just say natural log V, which means you've got to remember that natural log means logarithm with a base of E. Okay? There's a fair, now this change of base rule, you can actually change log base 5 of 30 to log base 10 of 30 over log base 10 of 5, natural log of 30 over natural log of 5. You can change it to any different base. So here's a non-calculator question that I think would be fair involving change of base.
So does ln equal ln e?
ln, natural log, just this part, just means log base E.
Okay.
So it's
how can you change what the log base 10 to log base e without having to do something?
How do you mean?
Like, aren't they different numbers?
Well, it's a ratio. You're talking about when I just had the change of base rule, when I just had log base 10 and log base E equal to each other?
Yeah.
Well, the change of base rule actually says you can change to any other base. Let me do this example and see if this helps a bit. Like if I said without a calculator, what's the log base 16 of 32? Now think about what this question is asking for a minute. This is asking what power, what exponent do I put next to 16 to get 32? Okay? It's not what do I multiply 16 by to get 32. That's kind of a good guess. That's not a bad guess because we know that 16 to the first power is 16. We know 16 squared is 256. Okay, so this answer is going to be somewhere between 1 or 2, and since 32 is closer to 16, it'll be closer to that. But how can we? That's what it rounds to. But how can we do this without? How can we do this without a calculator?
Log 16 divided by log 32.
Or no, log...
Well, that's with the calculator, because then you'd still have to know without a calculator what those bases
Oh,
are.
without a calculator.
Now, the thing is, change of base rule works for any base